Okay, so we're ready to look at the next problem, which is 422. 422 is a beam AD, and that's right here. So here is the body that we're going to be looking at. It carries two 40-pound loads, as you can see here at A and at C. The beam is held by a fixed support at D. This is going to be a different type of support, so we're going to be introducing that one here. And it has a cable pulling up here at B that is then attached to a counterweight. All right. Determine the reaction at D when the counterweight W is 100 pounds and when it's 90 pounds. Okay. So we'll be kind of doing this part A and part B. So to start off with, though, the body that we're looking at is just this beam right here. So we're going to draw a straight line A, B, C, D. And then we're going to add the information that we have here. So I'm going to start by creating my free body diagram. Okay. I'm going to put my convention in the upper right-hand corner. Okay. And I'm going to be drawing. Now there's a lot going on there, but we're just interested in that beam from A to D. So that's what we're going to be showing here. Right about that. Okay. It's going to be A. And then this is going to be D. Okay, I'm going to wait to put D because we're going to have some other things that we have to put in place. B is right about here. Okay, so this is going to be point B. And then we have two forces. We have one at C here going down, and that's 40 pounds. That's at C. And then we have another 40 pounds at A. Okay. This is point D. I think I'm going to be putting point D here. Switch it in just a little bit. Okay. And now we have to deal with our supports. The first support we're going to look at is B. B is the one that is attached to this cable that goes all the way over those pulleys, and there's a counterweight. It tells us that the counterweight is 100 pounds. So that means there's 100 pounds going down here, but that translates all the way along this cable. So what we have here is we have 100 pounds actually pulling up. Do you see that? It goes on the cable and then goes down here. So it's 100 pounds pulling up at B. So we are going to identify that as 100 pounds pulling up. Okay. So that's just another applied load. And it's just because it's attached through that cable to that counterweight. D. D is a fixed support. So let's go back to page 160. We have a fixed support down here. Okay, it's kind of like a diving board. I like to think of it. So we would put this on its side, if you would. We know that if we push, down here, this is going to kind of, be out there, kind of going up and down, if you would, because all of the support is here. Now, to fully support this, there are three reactions that we have to identify. The first reaction is going to be in the X, the second in the Y, so X, Y, and a moment, okay? Sometimes referred to as a couple, okay? But we're going to call it a moment. So an X, Y, and a moment at D. Now, here is where you kind of have to look. Are there any forces in the Y direction? I'm going to put my Y first. And you can kind of maybe see, okay, overall, I've got 80 going down, I've got 100 going up. So that means that the reaction net is going to be going up, all right? And we'll figure that out in our some of our forces. So since that's going up, I'm going to show dy going down, okay? And we'll find the exact value, but I'm going to show it going down. Then I'm going to have an X, okay? Right now, there are no other X forces. So I'm simply going to point at the point. I'm going to call that dx, okay? And we'll solve for its value. And then the last thing that we need to do is we need to identify an internal rotation or that moment, all right? I don't know exactly which way this is going to go, so I am going to I'm going to guess, I really don't know. I'm going to call this moment at D, okay? Moment at D, because that's around the support point, okay? So again, we have all these out here. It's kind of like everything is being supported here, and then we've got this, you know, kind of going there. So we're going to solve for dx, dy, and the moment for that fixed support, MD, okay? So you'll notice that we don't have any forces to break into components, so we can go right from our free body diagram into equations of equilibrium, okay? So might as well do some of the forces in the X right away. So sum of the forces in the X equals 0. I identified my dx going to the left. So I have a negative dx is equal to 0. 0 is 0. So there's really no supporting there. So I'm just going to call it positive, and my dx is 0. Okay. You don't have to switch the direction there because again, it's 0. Whether it goes left or right, it's still 0. All right. If there was an actual value and we had a negative that we got, then we'd have to switch the direction. But when it's 0, it's not a big deal. So we have dx identified. So that one's done. Now we need to do our y component. So we're going to sum our forces in the y direction equal to 0. Remember, you have to write these out for me every time. It's not sum the forces in the y, it's sum the forces in the y equal 0. So I'm just going to move along. I'm going to go negative 40 pounds plus 100 pounds minus 40, not 440 pounds minus dy. Those are all the forces in the y direction. So I set this equal to 0. Sum of the forces in the y equal to 0, equal to 0. And now my only unknown here is dy, right? So I'm going to add and subtract on, everything that I can. So it looks like I've got a positive 20 on this side, right? 20 pounds minus dy is equal to 0. I'm going to move the 20 to the other side. So negative dy is equal to negative 20. Okay. And those are going to be positive then, right? So the direction going down was correct. If you put the direction going up and you end up with a negative 20, then all you're going to do is you're going to change it to a positive number and you're going to switch that direction going down. Okay. Because you would have ended up with a negative value. You don't have to rewrite anything. But the dy confirmed because I ended up with a positive value going down. Okay. So dy is done, but I've got one more unknown, and that's the moment at D. Okay. So we need to solve for that. So I'm going to bring in my extra piece of paper here, and we are going to, as you can imagine, sum moments around D equal to 0. Now, before I write anything else, I'm going to put that moment at D. So this moment is literally around point D. I have it going in a clockwise direction. According to my convention, that is negative. So I'm going to start my equation with the negative MD. This is the moment I will be solving for, okay? If you don't add it right away, you'll forget it. And then you'll try to slip it in somewhere. You'll be like, okay, it's there. So I'm now going to put my finger on D, and I'm going to now rotate in the direction of the offset forces. So my first one is going to be 40 pounds times, I didn't put my distances along here. Add those. Probably were like, Kelly, you forgetting things. So 4, 4, and then 5 back. So let me see. This one is 4 feet. This is 4 feet. And then this is 5 feet. Okay. Yeah. So coming from D out to here, that is a total of 8 feet then. Okay. And as far as the direction of rotation, it is going to be going counterclockwise, so positive out front. Then I'm going to do my 100 pounds. My 100 pounds, I'm going to rotate. It's going to be clockwise, and it's going to be 100 times 5 feet. And it is going to be, oopsie, negative clockwise rotation, sorry. Okay. Then I go back to my 40 here. That is going to rotate counterclockwise, 40 times 4. Okay. And then my dy is on the point, so no rotation. So it's just these 3 forces is equal to 0. Now, if you don't add in your moment at D, there is nothing to solve for here, but you do not set it equal to MD. It has to be on this side. If you end up saying, oh, I don't have anything there, I'm just going to set that equal to MD, I'm on to you. It has to be on the left-hand side because it is a moment that we're summing around point D. And we're calling it moment D because that's what it is. So it has to be on the left-hand side, and then we have to set it equal to 0. And now this is our only unknown. So we're going to add them, subtract these, put them the other side, and we're going to solve for MD. So go ahead and do that. I'm pretty sure. So you'll notice here on this line, we have negative MD, moment at D, minus 20 pound-feet is equal to 0. I'm going to put that minus 20 pound-feet to the other side. It becomes a positive. I have a negative value for my moment at D. That means that I did not assume the correct direction. So all I'm going to do here, just like I did for the other ones, I'm going to make this positive. I will not leave a final answer as a negative. And I'm going to erase my arrow, and I'm going to draw it going the opposite direction on my free body diagram. Okay. And now I can put my box around my moment at D. So a fixed support, or sometimes called a cantilever beam, there are 3 reactions, an X, a Y, and a moment. And you have to solve for each one of those. Okay. And then here too, there's, I don't know if it's a little trick, but you've got to remember to put that moment. I like to do it right away on my sum of my moments side of my equation so I don't forget it. And then that's the unknown in that equation that you're going to solve for. Okay. Any questions on this one? All right. I'm curious, can you erase the minus sign for MD instead of putting it to a plus? Yeah, you can. You can. You can. So your question was, can you go ahead and erase that instead of putting the plus in there? Sure. And then I'm going to look, though, that you did the second part of that and you changed the direction up in your free body diagram, because I look in both places for your answers. That's why you have to have good free body diagrams that have nice, clear labels on them, and that your work, I can see what you're doing here so that, in the event, something I do all the time, just like, we've been seeing, is I look at your work and let's say there was a minus sign wrong up here. Instead of losing, for instance, the full 10 points on the problem because the answer doesn't come out right, I can see what you did and I can give you, most of the points and then just take off a little bit for that one little mishap. All right. Okay. Well, are there any other questions before we move on? All right. If not, then I am going to stop the recording for this one.